Hello there. Welcome to CXC Math TV. And today we're going to be looking at sets, or some persons might know it as set theory. A really nice topic. So first thing is, what is sets, right? Well, a set is just a collection of distinct objects, or well-defined collection of distinct objects, right? And these objects inside of a set, we call them elements. All right, so just scroll down to the bottom. For example, let capital A be equal to the set of vowels in the alphabet. Now, the elements or the members would be A, E, I, O, U, right? Because those are the vowels in the alphabet. So this A is the set that contains all the vowels. A, E, I, O, U, these are the elements of the set A. And that's all is the definition of a set, right? Now, more examples, right? Maybe we want to specify it a little bit more. So maybe, for example, the collection of vowels in the word probability. Probability has what? Vowel O, A, and I. In that case, right, set P, we could define the set as set P as A, I, O, right? And that would be the set of vowels from the word probability. Maybe we want the collection of integer values that satisfy this equation, x squared minus 9 equals 0. In that case, you'd solve the equation by bringing over the 9 minus 9, so x squared is equal to 9. Then we square root it, we would get x is equal to plus or minus the square root of 9, and in that case, you get negative 3 or 3. Now, maybe we want to look at the collection of great football players on the Jamaica national football team. And right now, you know, the World Cup just took place and Jamaica is not there. So maybe I can say, this is just my perspective, there's no great national football player on the Jamaican team, so the set is empty. When the set is empty right here, it's a null set. All right? We'll talk about that a little later on. Or maybe we want to talk about the collection of intelligent members of the Caribbean Union Committee. So intelligent members, we just list them out. Maybe it would be a whole heap of people like Anna, John, Bruce, Keisha, and so forth, right? And we could list out the rest of persons that we consider to be intelligent members of the Caribbean Union Committee, right? Cool. Now, the next thing is the set with no elements. We call them what? Null set. There's two ways we write null set. A null set is commonly denoted by the symbol phi, or sometimes you'll see it with brackets with nothing in it. The set notation bracket with nothing in it. So it's either the symbol phi or the set with nothing in it. Example, let A be the set of real numbers that satisfy the equation x squared plus 1 equals 0. Now in this case, if you're to solve this equation, you'd never get any answer. And so guess what? This is a null set. So the result, if you're to try to solve this equation, we get a null set. All right? Nothing is in there. Another example. Maybe I could tell you that we want to find even numbers. We want to find even numbers, right? That are also prime numbers for all numbers greater than 100. Now, there would never be any even number that is also prime when the number is greater than 100. So in that case, it's also going to be a null set. Next thing now is the types of sets. You have finite set. A finite set is one which can be counted. For example, maybe we want the set of two-digit positive integers less than 23. So less than 23, right? And you want two digits. So you're going to start from which number? Two digits. You start from 10. So it would be, remember, you want digits less than 23. So it's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. All the two-digit numbers that are less than 23. Now, an infinite set now is one that cannot be counted. It's just going to go on forever and ever and ever. So for example, the set of integers that are multiples of the number 5. We know the multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. And we keep going and we never ever stop, right? And so those are multiples of 5, right? It's what? Infinite set because we'd never finish. Next thing we want to talk about is cardinality of a set. So this is the common notation that you'll see for cardinality of a set or counting the elements of the set. So the common letter N means number of elements. The bracket here means number of elements inside of the set A. All right. So for finite sets, N in bracket A means the number of elements inside of set A. So for example, if we want, right, let's say we have the set of two-digit positive integers less than 23. We listed them out already, the 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We did. Now, if you were to count these up, these would be how many elements, right? Let's count them up. We have 10 is 1, 11, 2, and so forth. We're just counting them. So in counting them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So in that case, we say that the number of elements in the set is 13. Now, for infinite sets, we can't count the number of elements. We cannot find out the cardinality of the set. We don't know how many elements is in there, right? We can't definitely count it. So we use that symbol, this upside down 8, which means infinite. And that's it. All right, so for example, the multiples of 5 again, right? We keep going and going and going and going and going. And we never stop. Next is the universal set. The universal set. So what is this universal set? Now, the universal set includes all the elements in consideration of a particular discussion. So, for example, right, let's just look at an example. Maybe we want the set of natural numbers. So the universal set would be all the possible counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and so on. That would be the universal set. The set of integers, we list them out. All negative whole numbers, all positive whole numbers, and of course including the number 0. Alright, cool. Next thing now, we need to look at membership of sets. So let A be a set and let you have an element inside of the set A, but let's call that member X. Oftentimes, this is how we're going to write to show that X is an element of set A. So if X is a member of set A, we usually use this symbolic notation to show that it begins there. So we're going to write X is an element of A. So we use this E. This E means element of. So this is saying X is an element of the set A. So for example, let V be the vowels. What are the vowels again? A, E, I, O, U, right? So in that case, we could say E is an element of V because E is a vowel, right? So E is inside of V. Now B is a consonant, and so B is not an element of V, right? And that's a symbolic notation. Next thing to talk about is equality of sets. Now, two sets are going to be said to be equal if they have the same elements. Always remember, two sets are equal only if they have the same elements. So for example, look at this. At the top, we want the set of odd numbers, the odd positive integers not equal to the, sorry about that. Set A is a set of odd integers and set B is a set of prime numbers. If you're looking at odd integers 1, 3, 5, 7, 9, 11, 13 and so forth, then the set of prime numbers 2, 3, 5, 7, 11, you realize that set A have a 1 in it, B don't have a 1. We realize set A I mean have a 9 in it, set B don't have that 9. So they don't have all the same elements. So in that case, realize that A is not equal to B, right? Because they're not the same. But maybe we could restrict it and say the set of odd numbers between 4 and 8 and the set of prime numbers between 4 and 8, that would both give you 5 and 7. So in a case like this now, where set A is equal to set B, then and only then we can say they're equal. Now subsets. A while ago we saw the example with the prime numbers and the odd numbers, and we saw that the prime numbers was basically almost like a subset of the odd numbers, as keyword almost, right? So a subset of B is every element of A that is also an element of B. So subset just means you're within both the sets. So you're inside the smaller set and also inside the larger set, and so therefore the smaller set is a subset of the larger set. It's that easy. So this is the notation we're going to be using for each set A. A is a subset of B. This means A is a subset of B. A is also a subset of A. Please make note of that. Empty set is also a subset of B. Alright, so for example, the best way to see it is with some examples. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6. Notice 2, 3, 4, 5, 6 is in both set B and set A. So in that case, we say that B is a subset of set A. Then we have what we call union, the joining of two sets. So we use the symbol U. This U symbol means union. This U symbol means union. Or some people like to call it the inclusive OR. So if I give you a set A and I give you a set B, you just join the two sets them together and that gives us the union. Coming together, right? You get married, two families do what? Come together. That's all is union. So A union B in this case is going to be 1, 2, 3, 4, 5, 6. Alright, but then notice over here the ones that they don't have in common is 9, 10, 11. So drop that on. We have intersection now. Another word for intersection is both. So what's in both A and B? A and B. What is in both A and B? That's all. See it here, X is an element of A and X is an element of B. So, for example, let A be the set of positive integers and B be the set of prime numbers. What do these two sets have in common? So, underline it. Set A have a 2, set B have a 2. Both of them have 2 in common. So, in that case, we set A intersect B is 2. Now, A and B are going to be disjoint sets or null sets if what? If A intersect B is equal, well, my apologies. A and B are disjoint set if A intersect B is equal to a null set. Alright? Finally, the complement law. Now, if A is a subset of the universal set, then the A complement is everything outside of A, but in the universal set. That is A complement. So to show you on a diagram, let's say this is set A, then everything outside of it would be A complement. Everything outside is A complement, and this is our universal set. Alright, very easy. So here we have a Venn diagram. Alright, this is a Venn diagram. So just to represent it again, set A represents, doesn't even matter what set A represent, but then we always put a little U at the top to represent our universal set. Alright, so some possible diagrams for two sets. Sometimes you're going to see two sets on it. So notice in the first diagram, right, A and B are apart. This is what we call mutually exclusive events. We don't need to know the technical term. Mutually exclusive events. And it's mutually exclusive because in this case, realize that A intersect B is equal to a null set. Because these two sets, they don't have an overlapping point. In the second one right here, we notice that A intersect B, we can see it, it's the part that has shade red right there. Then for the third one, realize that set B is contained inside of set A. So B is a subset of A. That's the third diagram. Cool. Again, here we're showing you A and A complement. So no problem, A complement on the outside of A. Now, sometimes, let's say you wanted this dark shaded region, right? Let's say they ask you for this part. This, let me go on it. If they ask you for this part right here, this part would be A and not B if we wanted just this piece. This is A and not B. Alright, this is A and not B. In other words, this is finding A only. Alright, so A and not B. Alright, this right here, this part that's shaded, we already established that's A intersect B. Alright, now these are regions that we should know, right? R1 is A and B complement. So R1 is this region. And what do we know about R1? R1 is what? A only. R2, let's shade it in a different color so we don't get lost. R2 is shaded in black. R2 right here is just A intersect B. Now R3 is what? B only. How do you write B only? This area that I'm shading is R3. R3 is going to be B intersect A complement. That is R3. Then R4 is everything on the outside, and everything on the outside is just A complement union intersect B complement. Now, finally, these are the two most important formulas when doing sets questions. The number of elements in A union B is equal to the number of elements of A plus the number of elements of B minus the number of elements of A intersect B. And also the number of elements in A only is equal to the number of elements in A minus the number of elements in A intersect B. So let's go ahead and do these questions. Exam style. First one, if A and B are two sets such that the number of elements of A is 12 and the number of elements of B is 20 and the number of elements of A intersect B is 8, what's the number of elements in A union B? First thing, write down the formula. This is number of elements of A plus number of elements of B minus number of elements of A intersect B. So it's going to be number of elements of A plus number of elements of B minus their intersection. So that's 32 minus 8, which is 24. So in that case, it would be option B. Very easy question. Next one. All right, and so looking at question number 2 now, it says, in a class of 60 pupils, all do mathematics or physics or both. 4x does mathematics, x does physics, and if 10 people do both mathematics and physics, how many people do physics only? So let's go ahead and do this question. Alright, sorry about that, the mark going at the bottom. So the first thing we know is what? First thing we do know is if we're to create like a Venn diagram, right? If we create a little Venn diagram, right? If we create a Venn diagram, you have the physics, maths, and then you have the overlap. The intersection is 10, right? And then we know that 4x does mathematics, right? So overall it's 4x for mathematics. So mathematics only would be 4x minus 10. And then physics now, we know that x the physics, so this is 10, x minus 10 for physics only. Alright, and the universal set is 60. So what do we know then? Remember, there's two formulas we said that you must know. What are the two formulas? The two formulas you must know is elements, number of elements for the union. So M union P is equal to number of elements of M plus number of elements of P minus the intersection. You must know that formula. So this was 60 and it's equal to math is 4x, physics is x, minus intersection is 10. Let's bring this formula up to the top, right? So we're going to bring this formula up here. That becomes 60 equal 5x minus 10. Bring over the 10 to get 70 equal 5x. And so x then is 70 divided by 5. And we know that is 14. So remember, x was the number of persons at the physics. So how many persons at the physics? 14. 14 persons do physics, and that's it. Easy. So question 3, I want you to go ahead and pause the video and attempt this question. In a class of 40 pupils, students do either French, Spanish, or both, but must do at least one. If 18 students do both subjects and 30 do French, how many do Spanish only? Pause the video and attempt. Keyword: Spanish what? Only. Spanish what? Only. Spanish what? Only. So in that case, now we're going to deal with it. We know what? We know, again, it's French and Spanish. So number of elements in French union Spanish is equal to number of persons doing French plus number of persons doing Spanish minus number of persons doing French and Spanish. So the union, they said, was in a class of 40 pupils. And then how many do French? They told us French was 30. French was 30. We don't know Spanish, right? We don't know Spanish. Let's call Spanish Y minus the intersection. How many do both French and Spanish? 18. They said 18 do both. So minus 18. So in that case now, 30 minus 18 is 12. So that's 12 plus Y equal 40. Then which number plus 12 give us 40? That must be 28. So Y equal 28. Now you notice 28 is not there as an answer. Why? Because the question wanted Spanish only. So now that you get pretty much Spanish, then Spanish only, another way of writing Spanish only would be Spanish and not French. So it's S intersect F complement. So this, remember, it's equal to number of persons doing Spanish minus number of persons doing both Spanish and French. So in that case now it is 28 minus 18, and that gives us 10. And that would be option B. Easy. Question 4. It says, which of the following sets is made up of elements that are multiples of 3? Pause the video and write down your answer. Alright, so this one should have been fairly obvious. It is option D. Multiples of 3 are 3, 6, 9, 12, 15, 18, and so forth. Right? So option D. Question 5. Question 5 says the number of subsets of P is... So, number of subsets, always remember this. Write down this formula. Number of subsets is equal to 2 to the n, where n is the number of elements. N is the number of elements in the set. So in that case, it would be 2 to the n is 1, 2, 3, 4, 5. So it's 2 to the 5, which is 32. That'd be option D. Easy. Question 6. It says there are 25 students of Form A of a Form 4A who play either football or tennis. Of these, 4 play football and tennis. And if 6 play football, how many students play tennis but not football? So in that case now, pause the video and attempt the question. Easy. So first thing, what do we know? We know that we're talking about number of students that do what? Either they play football or tennis. Now that's equal to number of persons playing football plus number of persons playing tennis minus number of persons playing both football and tennis. Now football union tennis is 25. Equal number of persons that play football. It says if 6 students play football, so that's 6 right here. Now number of persons that play tennis, we don't know. Let's call that T minus the intersection, and they say 4 play both. So that's 4. 6 minus 4 is 2. So 2 plus T equal 25. So T equal 23. Now many is tempted to say 23 is the answer. No! They said those who play tennis but not football. Tennis but not football. This is it. So the number of persons that play tennis but not football is equal to the number of persons that do play tennis minus the number of persons that play both tennis and football, and that would give you tennis and not football. So just remember this formula, please. You're going to be using it over and over and over again. So in that case, it is 23 minus tennis and football, which is 4. We work that out, we get 19, which is option B. Easy. Wow! Alright, do this question for me. Pause the video and attempt. It says if the set R is minus 3, 2, 5, then the set R is a subset of... Hey! First thing, negative 3 is a what? Integer. It's a negative integer. This one is an integer. 2 is an integer. 5 is an integer. So it has to be just integers. It's positive and negative integers. Option D. Question 8. Pause the video and attempt this question. Alright, so let's go through it. So they want number of elements of F union G. What we know, that's equal to number of elements of F plus number of elements of G minus number of elements of F intersect G. So that becomes 7 plus 5 minus the intersection, they say is 3. So that's 12 minus 3, which is 9. Easy. Solved. This one, it says, which of the following describes the set that is shaded? Pause the video and answer this question. So the first thing, the portion that's shaded, right? We know that the portion that's shaded is what? It's inside of P, but what? Not in Q. So if it's inside P and not in Q, it's P and remember is intersection, not in Q. So Q prime. So P and not in Q. P and not in Q, option D. Easy. Alright, question 10. It says, set U is numbers 1 to 6 and H is 3, 4, 6. What is H complement? H complement means the elements outside of A. Elements outside of H. Elements outside of H are 1, 2, and 4 because the 3, oh sorry, not 4. Don't laugh at me. 3, 4, and 6, that would be 5. So 1, 2, and 5. Alright, 1, 2, and 5. That's H complement. This one now, it says the solution set for the inequality is, pause the video and attempt this question. First thing, in doing this question, you have negative 3x plus 2 is less than 14. So we need to subtract 2 from both sides. So we subtract 2 from both sides. So negative 3x is then less than, when you subtract 2 from both sides, 2 minus 2 is 0. 14 minus 2 is 12. And then what we do next is we divide both sides by negative 3. Now the key thing is when you divide by negative 3, you reciprocate the inequality sign. So this becomes x is greater than 12 over negative 3 is minus 4. So looking for x being greater than minus 4. X is greater than negative 4. And that is going to be option C. That is it. Question 12. It says, give us this universal set for U, P and Q. And then in terms of P and Q, 7, 8, 9 may be described as. Now what do we notice about 7, 8, 9? We notice 7, 8, 9, it's not in P and it's not in Q. So if it's not in P or Q, so notice if we combine P union Q, what would you get? You would get 1, 2, 3, 4, 5, 6. And so you wait a second, P union Q complement would be what? It would be what's not inside of P or Q, which is just the 7, 8, 9. Those that were left back with. So in that case, it is option A. Okay, question 13 and 14. Right? So question 13 and 14, it says, we have 1, 2, 3, 4, 5 for P, Q is 1, 3, 5, 7, and R is 2, 4, 6. Find P intersect R intersect Q. What's in common with all of these sets? First thing is, let's look at P and Q. We notice both of them have 3 in common, 5 in common. Go over to R now, but scratch that. R don't have 3 or 5, so guess what? P, Q, and R have nothing in common. Since they have nothing in common, all 3 of them don't have one element that's in all 3. So, null set. Wow. We want number of elements in P union Q. First thing, work out P union Q. P union Q would be 1, 2, 3, 4, 5, and 7. Which is how many elements? That look like 6. Option C. Easy. Nice. And the last question before we go, it says in the Venn diagram below, the set DF represents. The set DF, what does DF represent? Pause the video and attempt. So first thing is to look at what the set DF represents. This is DF, right? But DF is just what? Elements DF is just Y only. How do you write Y only? We're inside Y and we're not inside of X. So it's Y intersect X complement. That's option C. Wow. And so that concludes the worksheet part of it on sets. These are all the different styles of question they'll give you. I gave it in the form of a multiple choice, but of course, a lot of times you get the structured part for it, but it's very easy. I hope this video was beneficial. Make sure to just like, subscribe, and to keep practicing to get better at math.